Oh, Sheffield.
Excellent. Who trouble you know? Good afternoon, guys. Good evening, rather.
Right, sir.
Mm,
Good evening, sir.
what wanna do?
Sir, me vexing, sir.
Oh, who trouble you?
You, sir.
Jesus, Father, what me do?
You never send the recording.
To my Jesus. Hold on. And I saw this stuff, Guess what? You're supposed to be upset. And guess what? I'm fine. I'm fine with that. I'm sure by before the end of the class, they're going to still love me. Hold on. The recording came in. It came in, but I'm going to tell you, we've been having some serious meetings. This is what I thought today. Oh, God, we had a meeting from 10 o'clock. And after 3 o'clock, the meeting was still going on. Trust me.
Okay.
So I am at fault. Yes, I saw the stuff. Oh Lord Jesus, it's all you make me go in on my email now and I go back up and hold it for something to go do. No, guess what? These things will have to be action tomorrow. No, they will have to be action tomorrow. It did come in. I know exactly what happened, and I want you to believe me. Matter of fact, can I go to my YouTube channel? Guess what? Easy fix. I downloaded the stuff. The stuff is actually in the YouTube channel. Not that I go in there. It's in the YouTube channel, no, but guess what? I now need to move it from private to public. So it was downloaded because I know I did it. And I want you to believe me that I did it. So let me just, okay, so it's right there. So let me go to my account now and convert it from, oh Jesus, how do I do this now? And convert it from, see there? No, but it says 6 views. No. Hold on. Something is wrong. Manage videos. Videos. I have 6 views for that one. That was sent 5 days ago, and it was 3 hours. No man, this is it. How many classes have we had so far? Just 2, right? No, we had 3 classes so far. 3, right? The first one, I told you that I'm not sending that recording because we did a lot of housekeeping. Then we had one the last week Thursday. So this one should be last week Thursday. So where's the one that I did on? Hold on. Okay, plus 2. Nope. No, come on. I need to go back on. All right, I'm actually just waiting for another 2 minutes for the others to come in because there are 13 of us now. There were 12 of you earlier, but.
Hey, I'm new to this class. This is my first class.
Okay. I guess I need to tell you welcome, but you have to catch up because I'm not able to go through what it is that we've done before. So you need to get the notes. All right, let me go back into this stuff. Did I send you the notes though? And you guys received the stuff?
No, sir.
You're talking about the past papers?
Not the past papers, the
No,
document that I was
sir.
working.
No, sir.
The notes from the last class?
Yeah.
Last 2 classes?
Yeah.
Yes, it was in the WhatsApp group.
Oh, because Sash want me feel like I'm losing a screw, and I know that sometimes I do, but Sash, check your phone, please.
Can someone add me in the WhatsApp group, please?
Sir, there is nothing from the last class in the WhatsApp group.
I don't, me a second,
Whoever said that, I don't know what they're talking about.
All right, hold on.
Who's new? So I put your number in the chat, please.
All right, 1 second.
You're in the web group?
Yes.
Oh, okay.
My phone is filled with all of these notifications, so that's why I'm still scrolling. Hold on, because I worked on a document. To the point where I remember when I was preparing for class today, who was it? I think Lexton was asking about the algorithm for the stuff, and I said to myself, I don't need to bother send the algorithm since I put in that little table. 1201. When was last week's day? 23rd, 23 and 7:30. 23rd. Let me go to the 23rd quickly. I'm sure I extracted that stuff. That's logic. See there? I emailed myself the notes. I'm just finding it. I emailed myself the notes, guys, 7 days ago. Jesus. I emailed myself the notes on the 23rd at 10:40 p.m. and I did not send you the stuff. And for that, I am very sorry. So let me send it right now from 10:40. So share as PDF. And I'm sure I also did the recording at the same time. Sit then, Sash. If you know see the something, whenever you drop a little one note and say, sir, remind me about the something, we have to hold the teacher accountable to, you know. All right. So I sent you that. Yeah, man, I sent you that stuff that I did. Let me look at the recording now because I know I did it. I know I did it. All right, so that is that one. All right. Let me not eat up any more of the time. I know the recording came in. The recording came in on the class was the 23rd. Let me go back to the 23rd email. Honestly, I have to just go to all of this again.
Sir, I know you're all over the place, but you resent the second class PDF.
No, it's the
The one with the homework, that's the one you sent.
all right, no man, what you need to look at is all right, so what I do is because I'm on the same topic, I just recopied everything. All right, let me just go and just double check to see what it is before I speak out of turn. And yes, you are correct. What is wrong with me? You are correct. When was the last we had class 7 days ago? When was the last time? No, we had class today, this week. We had class on the 28th. All right, so that is for the person who just got added to the group. Clearly it's not for the rest of you. All right, guess what? In any event, I'm continuing with the worksheet that we did, that I would have sent you. So let me just do a comprehensive one and then resend that one at the end of tonight's class that I actually have up already. Share screen. All right, so let us just agree that for tonight's class, we are going to get up to anywhere here, even for me to just talk about here. So this is not there. I need to do anywhere up to page 12. So the aim of tonight's class is to get up to page 12. Now, I can get up to page 12 very quickly. Anything for that table? Okay, that's the last thing we did. I can get up to page 12 very quickly. And I'm at page 5, so I have 7 pages to do for tonight. That's my plan of action. Now, coupled inside of all of this here is my explanation, but of course I have classwork for you. I have work that is so assigned for you that you will do throughout the class. So what it is that we're going to be doing is just to look at the continuing what it is that we did with the the limit as x tends to infinity, and then I'm going to move to negative infinity, give you some questions. Let us see what can happen from there, and then we move on to other things. I remember having done this, we looked at some of these calculations by inspection. Now, and just to recap that last section that we did, question number 9, we and congratulations again, Jermaine. We looked at the stuff. We first need to identify which term in the numerator is the highest, and we recognize it's x to the 5th. And then we'll also need to look at which term in the denominator is the highest and recognize also x to the 5th. So we said to ourselves that everything else will tend to 0, and we'll leave our 2x to the 5th over 5x to the 5th. The x to the 5th will cancel out, so it would leave 2 to the 5th, sorry, 2/5. And that would have been our answer. And then for number 10, we looked again. Don't be fooled, because the 3x to the 4th is in the first position that you're going to divide everything by x to the 4th. Because when you look down here, you recognize that this is x to the 5th. So x to the 5th is actually the highest power in the numerator, and x to the 5th is also the highest power in the denominator. All right, so everything else will go to 0, and then we'll have or negative 7x to the 5th over 2x to the 5th, and that will give us negative 7/2, which is here. Now, even though I'm showing it this way, one still has to be very careful, because you can have some variations to it that you have to just have a very good and keen eye. And I'll show you how these work in just a few. Okay, so basically, and I'm just recapping what we did right here, because I want you to do an exercise for me now. Basically, what we did was to look at no, I did this stuff for now. You hold on there, because my headspace not where it's supposed to be, because I know I did the thing. See there? 29th at 11:50 a.m. All right, so I found it, guys. I know I did it. I know I have a lot on my head. Yeah, I know I did it. All right, so I found it, guys. So let me just send this off, because you're going to be doing a piece of work for me, and I want you to look at it. What I've done is I don't want to send you the full document, because I don't want people to go ahead, work ahead, and get confused. So I actually cut the document in pieces, and I know I did it. So I actually found it. So I'm gonna send it off to you now. Compose. So 1. All right, so let me PDF the file and send it off to you. All right, so going back to the document. So what we did here was to are you seeing my screen?
Yes, sir.
Yes,
Loud
sir.
and clear.
All right, cool. So what it is that we did here is we looked in the numerator, and the document is downloading for me to send off to you. So I decided to just continue. So we look into the numerator, and we recognize that the highest power is x to the fourth. We also look in the denominator and recognize here that the highest power is x to the fourth. Why do I have infinity over infinity? To say that it's indeterminate. I have infinity over infinity because the limit is tending to infinity. The limit is tending to infinity. So when I put infinity in here and do all my infinity stuff, I'm going to end up getting an infinitely large number in the numerator. But when I do the denominator in the same way, I'm also going to be getting an infinitely large number. So having infinity over infinity is also indeterminate. But sir, what you showed us in class last time was 0 over 0. Yes, man, I did. So 0 over 0 is just one form of being indeterminate. And then we have infinity over infinity as the other form of indeterminate. The other form of indeterminate. All right? So we know that it's indeterminate. There's something that we need to do. Something else that we need to do. You see, once you see the infinity something here, just start look for the highest power of yourself, the highest power in there, but you need to check to see that it's infinity over infinity. You have to check to see that it's infinity over infinity. And then you divide by the highest power. So that's all we need right here. X to the fourth over x to the fourth. So every term in the numerator is being divided by x to the fourth. Remember, look at the consistency of it. Every term in the numerator, Sash, check that for me, please, and make sure that is the right one. Every term in the numerator is being divided by x to the fourth. When I look at the denominator, I am going to be doing the same thing. Every term in the denominator too is being divided by x to the fourth. So the x to the fourth cancel.
Yes, sir.
All right, thank you, honey. The x to the fourth cancels and cancels here, so I'm just left with 1. X squared over x to the fourth is going to leave me 1 over x squared, 1 over x squared. And the 7 over 4 has nothing to cancel with, so I write it back. The x over x to the fourth over x to the fourth, see here, so cancels, leaving only 2. The x cubed cancels with 3 of the x's in the denominator, leaving 1. So I'm going to have 6 over x. See it right here? And the 2 over x to the fourth has nothing to cancel with, so I write it back. Now we did an exercise, which is here, and we said to you, as x tends to infinity, all of these fractional forms with the numerator being a constant will all tend to 0 as x tends to infinity. And so we'll prove it right here. Won't go through the proof again. We did that extensively last class. So all we are left with now is going to be 1 minus 0 plus 0 over 2 minus 0 over 0, which really works out to be a half. All right? Then what I asked you to do by inspection is to see if you could tell me what was happening here, and you were able to do it. You were able to do number 9. You were able to also do number 10. Now number 11 is what it is that I'm going to ask you to do for me. You know what? Forget it. You know why? Because the document that I just sent you contains the solution for number 11. The document I just sent you contains the solution for number 11. So what I'm going to do, I'm going to walk you through number 11. Then we're going to press pause. Then I'm going to ask, let me just double check to see if it is. Yes. So that number, my number 11 is your number 10 in the document. So, you know, God has a very good sense of humor. You know what just exonerate me a while ago to prove to you that I did copy this information before? Can you do these by inspection? Look at my screen. Can you do these by inspection? Look into your WhatsApp. Can you do these by inspection? You recognize the first question under that is question number 8? Talk truth. Look at answer now, please. Anybody, somebody? Not seen it yet?
Yes, sir. I'm seeing it.
Yes, sir.
You see that? And what number is this one right here, so?
9.
Number 9. Because when I did this, I prepared a question for you. Maybe I need to do that question. I prepared a question here, and I don't think you don't have this explanation, or did I put the explanation here? I did some more work on the document after I downloaded that one. This one, do I have this one here? Because I put this in bold because I didn't want to miss it. But you know, we don't have to do that one. You can do that one in your spare time. That would be number 3 or number 2 for that one. Right. So after number two with the 1/3, based on the conversation, I added something right here. And then I added this question. So these two pieces of information are new. But what will happen is that when I send the document again after class tonight, you can discard, oh, I should tell you that. So the first document that I put in the group tonight, we can now officially discard that one. And then for now, you're going to be using this one. And then every time my documents will have the title, Unit 1, Limits and Theorems. So every time I send a new document for limits and theorems, it will be the updated version of what it is that I would have sent. So I would recommend that you don't go ahead and print just yet, right? Until I would have completed Unit 1. So when I complete Unit 1, I move to Unit 2, then it can print Unit 1, because I can go back at any point in time just to add a thing or two to help you with the explanation. Is that understood and agreed upon?
Yes, sir.
All right.
Clear as mud, boss.
Cool. All right, so let us go back now to this one. I'm going to do number 11. I am not going to spend time on the ones that I have the solutions there for. What I'm interested in is maybe doing the ones that I don't have the solutions there for, just to give you an idea as to where you are. Okay, so let's go. So let us look at number 11, what will correspond to the number 10 on that sheet that you have. So you look at the question. The question says, find the limit as x tends to infinity of x to the 5th plus 4x to the 6th minus 7x to the 4th, all over x to the 4th plus 2x to the 6th. So we need to find the limit. And you know what? Funny enough, I want to spend some time today in all that we're doing to go into the past paper. So I'm putting you on guard. I'm going to ask anybody in the class, maybe to just be prepared to project. No, but it's in the groups. They don't have to do that. Thank you. In the groups, they don't have to do that. So we'll go to the WhatsApp group and look at the question that we're going to be working, because I'm going into the past papers today to start working some questions from the past papers so that you can get a feel as to how the past paper questions are structured. So you're in the past paper, and there are questions like this in the past paper. You're in the past paper. You see the limit as x tends to infinity of this function here. And the question says to evaluate. And you say to yourself, okay, what sir says is look in the numerator and find the highest power. Which one is the highest power? 7x to the 4th. 7x to the 4th?
No, sir.
No, sir.
X to the 6th. Right. 4x to the 6th. Good. Excellent. So what I'm going to do is to divide throughout each term in the numerator as well as each term in the denominator by x to the 6th. So this now becomes x to the 5th over x to the 6th, see it right here, so 4x to the 6th over x to the 6th, see it right here, so this negative 7x to the 4th is going to be divided by x to the 6th, see it right here, so then I flip to the denominator now, x to the 4th divided by x to the 6th, see it down here, so and 2x to the 6th divided by x to the 6th, right down here, so. And then what I didn't do is to show you the cancellation, but you can see it. Let us work through it. The law of indices says a to the m. Did I put it anywhere up here? No, I didn't. No, that's not what I'm looking at. Sorry. All right. Just allow me to copy something into what it is that we're doing so that I can further explain what we are about. So the laws of indices are very important stuff. Very, very important stuff. We can't not be respectful to those laws of indices. So let me just do a quick recall. A to the m, so we're subtracting. So copy, and then I'm going to paste it right here now. So recall. . All right, recall a to the m divided by a to the n. A to the m divided by a to the n is going to be a to the m minus n. Watch me. The bases are the same. A and A, the bases are the same. See here, the base is the x and the x. So the bases are the same here. So I'm saying to you, once the bases are the same, I am going to say a to the m over a to the n. So it's going to be a to the m minus n. This is when it is at regular division. So what is happening here? And I should also recall that one. All right, let us work with this one. So this is going to be 5 minus 6. 5 minus 6 is the same thing as -1. Talk truth. 5 minus 6 is -1.
Yes, sir.
Yes, sir.
All right, cool. So I'm going to show you something here because I want you to see it. Also, 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 a to the negative m. So we would have gotten x to the minus 1, but a to the negative m is equal to 1 over a to the positive m. So when we say 5 minus 6, we're going to get -1. So we're going to get x to the minus 1. But x to the minus 1 is the same thing as 1 over x to the positive 1. See here, 1 over x raised to the positive 1. So that's how we get this term right here. So I'm giving you 2 recalls from indices so that you can understand how it is that we move from this point to this point. Is it mod or is it okay?
Clear, sir.
Good.
Yeah,
And then
that's
of course,
good.
and of course, the same way we can say x to the 6 cancels with x to the 6, you know. But let us look at this one now. X to the 6 over x to the 6 is x to the 6 minus 6. X to the 6 minus 6. 6 minus 6 equals 0. 6 minus 6 equals 0. So let me give you the law that says anything raised to the power 0 is going to be 1. Anything raised to the power 0 is going to be 1. Anything raised to the power 0 is going to be 1. All right, so I gave you 3 laws right there. 3 laws of indices. And this one is going to be just that one here, and 1 times 4 is 4. And then now, and another way of looking at it is to say x to the 4th over x to the 6th. All of this 4 will go into this and leave only 2 remainder. So it's going to be 7 over x squared. See it right here, so I'm giving you several ways to look at it. So none of you should say that you don't understand. Let us look at this one here. X to the 4th over x to the 6th. Everything here in x to the 4th can go into x to the 6th and leave x to the 2nd power. So it's going to be 1 over x to the 2nd power. See it here, so 1 over x to the 2nd power. And these x to the 6's will cancel to leave me just my 2, which is right here. Now remember, once we have a constant, yes, sir.
That's 7x to the 4th over x to the 6th. You said 4 into 6 would give you 2, but wouldn't it be -2 if we're using the law here?
Very good. Excellent. It will be a to the minus 2, don't it?
Oh.
Yeah, man. And then when we convert it, now we get 1 over a to the positive 2. So very good, Ryan. You are seeing. Very good. Very good. All right. Now, so as x tends to infinity, meaning say, Lexton, this is you. See here? As x tends to infinity, when the bottom piece here get large, it goes to 0. When a piece down here, so the denominator gets large, it goes to 0. When this gets large, it goes to 0, but it goes to 0 very slowly, but it goes to 0. The one here, the denominator gets large, it goes to 0. So this is a proof for this, all right? So I can again make my statement without having to prove it. I don't have to prove it because we prove it in class already, so you can use that now, and that's why it's called a theorem. So once it is that we work with the theorem and we can recognize that the theorems work, we can use the theorems now in whatever calculations we're going to be using, all right? So we can understand that, so we can know that this, and this will all go to 0 as x tends to infinity. So what I'm going to be left with is 0 plus 4 minus 0. See here? 0 plus 4 minus 0 over 0 plus 2. 0 plus 2. 4 over 2 is left, and 4 over 2 is going to give me 2. All right. So you have that document in front of you, and you also have it on screen. What I want you to do for me is I want you to look at it. Let me bigify it somewhat. I want you to look at it. I want you to, number 11, you're number 10. I want you to look at it here. Take a minute or two, no more than 2 minutes, to look at it, to see if you understand all the steps that I would have taken in arriving at my answer to be 2. And if not, I'm going to ask you to ask me whatever questions, because I'm going to give you a few to do. I will go through number 12 with you also. And then I'm going to give you, I think, number 13 that I did not do. I didn't do the solution for 13, right? It gets more interesting. I didn't do the solution for number 13. Are there any questions?
All right, sir. You hear me?
Loud and clear.
All right. So I didn't get the full understanding of the table. So that now when you talk about whatever the zero going slowly or something like that, I don't fully understand that part.
Fair enough, Sash. All right. Is that the only question, or you have another question?
No, sir. That's the only one.
All right, good. No problem. I'm more than happy to answer you. But here, how I'm going to answer you now. Is there anybody in the class that understood the point I was bringing across in this table? Who you know?
It's just that the
Come on, Sash. Sash, you don't need to justify 20 bunches. Me go do it for you.
The larger the indices, sir, the faster it go to 0.
The larger the indices?
Yeah, the faster it go to 0.
And where you find the larger one? Where you find it? All right. Okay, Ramesh. So I know what you're saying, but what you're supposed to be saying is that when you investigate the denominator, the higher the index, or the is the quicker it goes to 0. Yeah. Okay. Fair enough. All right. Okay. Thanks, Ramesh. You get the gist of it. So let me go again. Sash and others, for those of you who are just joining, you have an opportunity now to see this table again. Is this view okay, or you want me to go to the other view?
Bigify it, sir.
What was that, Sash?
Bigify.
All right, I will bigify it for you, dearest. I will bigify it for you. All right, so let me go back up. Nope. The other up. All right, right here. Okay. So this is what is happening here. So what I'm trying to do here is to prove to you that as x tends to infinity, that this term will tend to 0, that this term will also tend to 0, that this term will tend to 0, so does this term. All right? So what it is that we did, these are my x values, these are my infinity values. Matter of fact, let me change it and not just call it. No, they're actually my x values, but yeah. Rockstone, undo. Right. So they are my x values. They are my x values. Look at what does that mean. So I'm looking at when x is 10, when x is 100, and when x is 1,000. So this is 1 over 10 squares. 1 over 10 squares, because I'm substituting the x values here. 10 squares is 100. So I'm going to have 1 over 100. And 1 over 100 in decimal form is 0.01. Then when I move to this one now, I'm going to have 1 over 100 squares. And 1 divided by 100 squares is 0.0001. And then when I go to 1,000, I'm going to have 1 over 1,000 squares. And 1 over 1,000 squares is going to give me 0.000001. So the point, Sash and others I'm making is, if I were to go to, I don't want to do that, you know why? All right, never mind. Do it.
How you put it in the calculator, sir?
No problem. That's the same question Lexon was asking. If I go to 10,000 now, after 1,000, 10,000, ouch. You're going to press 1 ABC, open a parenthesis, ten, close the parentheses. Where do I find that? Upside down V for you guys. Then press 2.
Number 6, sir.
Right, number 6 on the computer, right? And 1 ABC, that's the division, open bracket, and then equal. Try that for me, please.
1 over 100.
1 over 100, and then, so you're gonna get, oopsie daisy. All right, you know, I should be using the software to do this, you know. 1 A B C, open parenthesis, 10, close parenthesis, squares. No, let me not do it like that. You're going to get 1 over 100. 1 over 100. Then what you're going to do from here, you're going to then press F to D. Press the F to D button for me, please, or S to D. Which one your calculator says?
What's that?
F to D or S to D. Look on your calculator to see if you say F, F as in Frank, D as in dog. Look to see if you see F to D. I mean, yeah, you will see F and an arrow and then a D, or you may see S and an arrow and then a D. Anybody sign that? Look over your 7, 8, 9 button. It will be, it normally comes close to the delete button. So the F to D is changed from fraction to decimal.
I say STD.
No, sir, we don't want that.
Okay.
I see D over C. I see it's an S to D there.
All right. So the good calculators will have F from fraction to D decimal. So if you have like a Kenko or a one of them, you have a Casio?
Yes, sir.
Sir, the Casio has S to D.
Yeah, man, that's what I know. It's supposed to be S to D. Look, Stash.
Star me have one of the cheap ones, Star Mate, and it not have nothing named so.
You better go throw that away.
Star me just buy it. The tax so.
You know, when you move to calculus 2, you may have a problem. Sash, do me a favor, take a picture of yours and put it in the WhatsApp group for me, please.
Sasha, it's supposed to be over the delete button.
Right, it's supposed to be over the delete button, yeah, man. Sash, look over the delete button and see if you see it.
Yeah, take the picture, sir, because you can't see it.
All right, no problem. Take the picture, pick and put it in the group. And you will find it over the delete button. Sasha go buy every one of it curry lobster for lunch tomorrow.
Hey, take your time, sir.
Incidentally, there are a few of you, when I looked at my stuff in preparing for the class today, there are a few of you who don't open your mouth and talk to me in class. Sean Anderson, you're one of them. And you are going to open and speak to me today, Mr. Anderson. Thank you. Who is? I've heard from everybody. You are new. You are new. Okay, Sean. That was just a load of Sean. All right. Sash, you know, send us something?
Yes, it's in the group, sir.
It's in the group? All right. Show me one load of Sean, that's why. Or it just came in.
Sure.
No,
Sir,
I
my
find it
calculator
on mine
different.
as well, sir. You know.
Sir, I think my calculator different.
Okay. Which person did you say this one?
I'm sure you need a new calculator.
Absolutely. Absolutely. I'm sorry to disappoint you, Sash, but
F.
all right. So what you need to and the picture that you need a new phone too.
And a new laptop.
All right. No, it's not there.
Oh, yeah. ETCL.
Sir, mine on my one, I look on it because I mean, I have the good phone.
Oh no, hold on, the man. No, at the star make me look on. Sorry. No, how me for do that? At the star make me look on for real.
Sir, Sasha won't have it neither.
Yeah, session I want no. Strange though. Wow. All right, so I need to find another way to.
Sir, look like a China my one making them. I see that AB something there, you know.
No, my ABC over the top part, man, under the. Oh, you're not seeing this on yours, this, you know?
I said my one in the group, sir. Look.
Yes.
So which can you have that? I need to
Oh no!
right.
Oh, you're using. Oh, you're one. What the heck? Advanced.
My one at the Casio, sir. The last Casio.
Okay.
Let's turn off the SD, you know.
Your one have it next time.
Did you write our delete button, sir?
Yeah.
No, I have SD.
Legs and have one similar to mine.
I don't have the AB/C button.
I don't have no AB.
Okay, all right. So let me just talk about okay. Who is the FX82 ES Plus?
That's Lexton.
My
Oh,
one, that, sir.
Okay, Lexton. So your one is a little sophisticated, better than the no mesh one. All right. So you see where you see the ABS.
Yes,
is
sir.
below it.
Look under ABS. Your one is a natural display calculator. So if you look up, if up top in red, it says natural. So you can go ahead and write your fraction as a real fraction to give it a natural display. So when you press that button, the shaded one is the numerator and the unshaded one is the denominator. So you put in one and then just press the button for me. Press the button. You're going to use the replay button in the middle, that big something there in the middle.
Yeah.
The up is to go up, the down is to go down, and so forth and so on. You're going to press the up button to go up to the numerator, put in 1, and press down to put in 100, and then press equal. Where you get?
Sir, wait a second. Press the 1 and then the.
Put 1 in the numerator.
Yeah.
And then put the 100. No, don't put the 100. Put 10. And then press the X squared button beside it. 2 buttons away from that. Press the S squared button.
Wait, so 1/10, sir, and then X squared.
And yeah, but the squares you want to square the denominator, you know.
Yeah, man, have it now.
Good. And then press equal. And we get 1/100.
1/100, yes, sir.
All right. Press the S to D for me now.
Repeat.
Press the S to D, the button over the delete button.
S to D. Oh, it gets 0.01.
Magic. Right? So that's what it is that you have done. So you've just converted yours to decimal, all right? Now, let me just, right, so that's one thing. So let me just show you something here. The natural display calculators, for me, are the better type calculators. Well, I won't show you that just yet, next one. So you know how to work yours. Charlene, let me see yours. Charlene, you have the same one, Charlene. You have the same thing, mums.
No, sir, I was just telling them that they're going to need one similar to that for calculus 2. Because there's a button there that's not on the other types of calculators.
Yeah. So I would speak to Charlene a little later on to show her how to use these, because she can actually, besides the CAL button, she can actually do an integration on her calculator. Not all types of integrations though, just some very limited one, and she can do some differentiation on hers. Not all types of differentiation, it's very limited. But I can work with you, Charles, to show you how to do that. But I'm a little concerned though. I'm a little concerned about.
Yes, sir.
I'm gonna go back up. Sorry, I'm not taking away class time, but it's important for me to show you how to use a calculator. And I'm a little concerned because I don't know why I'm not seeing the STD on this calculator. So it has to be another button. And because I'm not seeing DRGs not hit, it has to be there somehow. And I don't want to go into your mode and interfere with anything there because I'm not there to reset it for you.
No, but I think about calculus when I'm doing this.
Huh?
I wonder if they weren't thinking about calculus when dealing with Casio.
No man, this Casio also is a very good one because I mean this one is almost like Charlene, but the version below it, because this one can also work differentiation and integration. The one that was sent by you offering. So I don't understand that. And so finally on this HP my computer, not my calculator.
Sir, so question, my calculator can work everything then?
Who is Lexton?
Yeah.
I won't say everything because it won't be able to work. Like Charlene's calculator won't be able to work an indefinite integral. It can only work a definite integral, and it's only some functions that it can work.
So
I will show you.
Calculator then. What are the best calculator, sir?
The one that Charlene has is a good one. I mean, I had a very good calculus student some years ago, and because she did so well in class, I took my calculator and I gave it to her. So I had something a little bit higher than what Charlene has. All right, so these other calculators don't have it. But anyhow, so you have to go and use, oh Lord, the super key is not that enough.
Sir, I'm retake the picture. It looks like a better now.
Sir, when you're done, just send me a recommendation in a group. Okay, but
Sure.
I need that calculator, them in, sir.
We'll do, Papa. All right, Sash, I'm seeing it now, hon, but it really
Now we're
it's still not work out for me, yeah. You know, and I'm just gonna put you guys on. I hear Kelvita said that she just went and bought a calculator. You know, they're selling calculator now for $500, and them selling calculator for $4,000. And you may say, why am I going to buy a calculator for $500 when I can use, I mean, for $4,000 and I can get a $500 calculator? You actually pay for what you get, yeah? And you know, sometimes it miscalculates, and students are actually putting in the correct figures and it giving them all the stuff. So I just say to students, invest in a good calculator. Just invest in a good calculator. So,
sorry, a flow calculator.
A flow calculator? You're too wicked. No, you don't have a flow calculator, man. You have to go show me one so we can say yes, me see it. All right, it's not there. All right. All right, Andy. You know, clearly you went to that other school on that other side of North Street. Clearly, it's not the correct school that you went to. All right, let's go. All right, so Sash, believe Lexton when Lexton put it on his calculator that he got 0.01. All right, so 1 over 100, when you convert it, you really get 0.01. Now, if you do 1 over 100 squares, you're going to end up with 0.00001. All right, and if you do 1 over 1,000 squares, you're going to get that. Lexton, you have a good calculator. Charlene, you too, because both of you are using natural display calculators. Do me a favor. Put 1 over 10,000 squares and tell me what you get. 1, 2, 3, 4, 7. 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6.
Sir, my own say 1 times 10 to the negative 8.
Very good. So what it is?
Yes, sir.
Right. You see, because it okay. So let me just do a quick class on standard form. So look at what is happening here. Look at my calculator. Look at my screen. So the decimal point is here. So how many places do I have to go to get the first whole number? I'll go 1 space. That's 1. 2 spaces. 3. 4, 5, 6, 7, 8. So I need the first whole number. So this answer is indeed 1 times 10 to the negative 8. When I go to the right, it's negative. When I go to the left, it's positive. When you're doing standard form, you have to be very mindful when you're doing standard form. Standard form is going to be the opposite. All right. And you know, there's a reason I didn't want to do this, because this one going to give me like about 1, 2, 3, 4, 16. This one going to give me way too much. So I don't want, that's why I didn't do this column, this row. I'm going to take it out. This one going to be way too much. This is going to give me way too many decimal places, and I don't have space for that, because this one going to carry me up to 12 decimal places. Let me see this one. 1, 2, 3, 4, 5, 6, 7. Okay, it can hold. Check that one for me, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
7 times 10 to the negative 16.
Negative 16? 1,
Yes.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, this is not cutting it. I ain't going through this thing here with this one here. You get the gist with the delete row. You get the gist with the with these ones here. All right. So, Sash, what I'm saying to you is I'm just evaluating this fraction. When I evaluate the fraction, the point I was making here is that because this term is raised to the 4th power. You hear what we got a while ago? 7 times 10 to the negative 16. 7 times 10 to the negative 16. 7 times 10 to the negative 16. Let me do it this way instead. 7 times 10 raised to the negative 16.
So it takes a longer time to reach whatever you want.
No, man, it goes there quicker.
Okay.
It goes there quicker. So I get to 0 quicker right here, because when I put that right there, this is saying 0.15 0, 0.0000000000000000, and then a 7, right? And this one is going to be 1 times 10 to the 8, negative 8. Copy, paste. 1 times 10 to the negative 8. Bam. All right. And this one here, what that one works out to be, please? Somebody read quickly and tell me. 10,000. 6 times 10 to the negative 4.
By 3 0, sir.
It's 3
6 times 10 to the negative 4.
Right. And this one going to be 2 times 10 to the negative 16. 2 times 10 to the negative 16. All right. So Sash, what I'm saying to you, honey bunches, is that, and all of this here is written in standard form. The point I'm making to you, Sash, is you notice this is negative 16. Then, sir, why this is negative 4 and this is negative 8 and this is negative 16 and one and negative 16? Is it because of this x to the 4th? As Rami says, it gets closer to 0 much faster because I'm raising this to a big power, which is 4. All right. So this one gets to 0 way faster. Right. So if you look at this, you recognize up in here when I have 10 that I have all of 3 decimal places, 3 zeros before the whole number, before the number 7. 3 zeros before 7. When I have no 0 here, so I'm only have 1 0 here. So this one says that this one is the slowest, followed by this one, and then 2 you're fast out of the block. That's the point I was making. This one is still the slowest because I have only 1 0. This one is the second slowest. I have 3 zeros, but watch this. 1, 2, 3, 4, 5, 6, 7 zeros. That one also have 7 zeros. So these two will have the same number of zeros. That's why they have the same number of power as negative 16. Right? So this one is still slow out of the block. Look here, to the negative 4. That one I reach negative 8. That one I reach negative 16. So the higher you go, you recognize that all of these will tend to 0. All these numbers are zeros, you know. Of course, with the exception of this one here, because you could round this off and get 1, right? But remember, based on the calculations that we have been doing, we never normally start with the intuitive approach. Let me show you what I'm talking about. With the intuitive approach, we never normally start with the first answer.
Yeah.
We never normally use the first answer. We continue doing the stuff first until we get to a point where we can have a truer picture as to what is happening. See, we will never start, never normally start with the first answer, because this first answer would have given us 2.1, when in fact the limit is actually 2. All right. So we just need to be very mindful of what it is that we're doing right there. Okay, let us move. Sash, is it
Yes.
clear, hon?
Clear as mud, sir.
Good, 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 good. I love it. All right, did I do that one? Okay, so I was saying to you that I'm going to go through my number 12, would be your number 11. And I really want you to, I will go through it, but I want you to follow what it is that I'm doing. Should, in case you have a difficulty, ask me at the point that you're having a difficulty. All right, let us go. So the question says, for 5 marks, evaluate the limit as x tends to infinity of 3x to the 4th minus 4x cubed minus 7x all over x to the 5th plus 9x. And I'm saying to myself, oh, they're embarrassing my intelligence. What sir says supposed to do is to look on the something to see the highest power. So I check in for the highest power. X to the 4th, x to the 3rd, x. Then I x to the 4th, right? I say no. X to the 4th in the numerator. But the denominator says x to the 5th. Blow. Then after the two of them are not the same something. So which one is supposed to divide the numerator and the denominator by? The highest power in the function. So it's x to the 5th, not this x to the 4th. Please, nobody don't make the mistake of dividing the numerator by x to the 4th and then the denominator by x to the 5th. I want somebody to speak the truth. If that thought came to mind, tell me. I want somebody to speak the truth. All right,
Yes,
great.
sir.
Sorry, it came to your mind?
Yes, sir.
Yeah, man. And you know, and I mean, I won't kill you, because I too was a student, you know. And you know, I don't know if this came to my mind, but it's something that I would have thought about, which is why I said it. Right? So I'm saying this to say to you that I don't, and I would have seen it as a teacher. I don't want anybody to say I am dividing through by the highest power in the numerator and then looking at the denominator to divide by the highest power. And also, sir, say you look for the bigger one and you're going to divide the two of them, the numerator and the denominator, by the bigger one. X to the 5th is it. So the numerator is going to be divided by x to the 5th. So I'm going to have every term. Yes, Yannick.
So is the IS in the function, not the numerator?
Ah, so somebody never get this something with that thought about. Very good.
No, earlier, no, it's not that, sir. Earlier you said look for the IS in the numerator.
And the denominator, and then
I've written that down.
No, man. What I said is to look for the highest in the numerator, and we're also looking for the highest in the. Hold on. See here, we just did this question in Yannick. We're looking for the highest in the numerator.
We were doing that. I heard IS in the numerator alone.
No, and
yeah,
I'm
that
no.
is what I'd written down, so that is why I'm getting clarity now.
Okay, so I'm happy that I'm going through this question again, because what I said is the highest in the numerator, and we're looking also for the highest in the denominator. So the ones that we've done before, and that's why I mixed it up, Yannick, because you see the ones I gave you. Look here, let me go back up here.
Oh, they both are the same.
Very good, sweetie B. So I am teaching you the topic. Start here. I'm teaching you the topic where me give the two of them right over each other so you can see it. And then now, when I move on from there, so I give it to you again when it's over each other so you can get your confidence. And guess what? When I see 3 times over each other. But when we reach right as or no, we put them over each other here to see if I'm going to confuse you. But Jermaine, where's Jermaine? He's not a class tonight. I'm going to charge him $1,000.
Him not pay him light bill, sir.
You not pay him light bill. All right, cool. So what I did, Yannick, and I'm happy I'm having a conversation. What I did, Yannick, is trying to bring across a point, and I put the same numbers right here. And I said, what is it? And I was hoping that somebody would have said that, but Jermaine said, no, sir, it's -7/5, because he recognizes now that the highest powers were there. So if you look at it, Yannick, all the questions we have done so far, the same highest power in the numerator is the same highest power in the denominator. Talk truth.
Yeah, I wasn't at class on Tuesday, sir. So
that's why you have the problem, honey bunches. All right, never mind. All right, never mind, honey.
No, that is why I'm saying I'm working based on something you had said earlier, which is what I wrote down.
Okay, all right, cool. Got you. You got to understand. Got you, honey. Got you. Right. And then this one, no, the two of them again was the highest. So what I'm trying to do now, and maybe I can put a little notation here. All right. So I'm going to trickify you guys. Right? I'm going to trickify you guys here now. So look at what is happening here. No, next thing you're going to tell me is I don't know English, so let me take it out. Look here. In the numerator here, you recognize that the highest power is x to the fourth. But in the denominator, it's not the same x to the fourth like we would have been doing in the other questions. This one has a different highest power. Which one we're going to use? Sir did say the highest power in the function. The highest power in the function that we're interested in. And that's why I said to you just now, don't divide the highest power in the numerator and then the highest power in the denominator. So you're going to be looking for the highest power in the function, and the highest power is going to be x to the fifth. So each term, 3x to the fourth over x to the fifth, which is here, 4x cubed over x to the fifth, which is here, negative 7x over x to the fifth is here, x to the fifth over x to the fifth is here, and 9x to the fifth over 9x to the fifth. But before we do that though, before we get to this stage, we need to check to see if it's indeterminate. And you can check very quickly to say infinity to the fourth is big infinity minus infinity to the third minus another infinity, still infinity. And infinity to the fifth plus 9 times infinity is infinity over infinity, which is why I have infinity here over infinity. All right, positive infinity, that's a matter of fact, over positive infinity. All right, because this x to the fourth is going to be a bigger number. So even when I subtract these two numbers here, it's still going to be a positive x to the fourth. Sir, how you know that? No problem. Thank you for asking. You recognize that this big x to the fourth gone the way to 16, and the one with the square only be at 8. And if I had it at cube, it's still going to reach 16. All right, trust me on that. Because it is, when you do something like that, it is being squared exponentially. You know, let me say it. That's why COVID is very difficult to get rid of, to the point where I was reflecting today and said to myself that for the rest of our lives, we have to go live with COVID for the rest of our lives, because there's a country, Jesus, I'm trying to remember the name of our country. There's a country that has no COVID cases. Anyhow.
I think it's Thailand. One of them sign a country there.
Yeah, but one of them have no COVID cases at all, right? And then there's another country that 100% of their population is vaccinated. But here's the point I'm making. If Jamaica gets to a point where we almost have herd immunity, and we have just one person behind Jesus way back in the country who have COVID, and then now them family members decide, say, them are going to look for them and go down there and say, well, go on. That one person with 5 family members go down there to go check them family member, comes back, that those 5 people are now carriers of the COVID virus. And each of the 5 persons will go to their different workplaces, and each person can infect 10 other people. All right? So you move from one person, one last person in Jamaica for habit, you know, one dege person in Jamaica for habit. And then now you get into contact with 5 other people, and you give those 5 people, that one person will transmit that virus to 5 other people. And each of those 5 persons would have go to their place of work because they're asymptomatic and don't know them have the virus. And each of the family members will end up go to work and give 10 more people the COVID virus. So right there and then we don't have 5, you know. So it's 5 times 10 is 50 plus the 5, 55 plus the 1 is 56. So you see how exponentially in only 3 different sets of exposure, or 2 exposures, we get the numbers increase. So which is why the US could report over 5,000, 6,000 people a day dying from COVID because of the exponential treatment. This is the sort of exponential treatment I'm talking about. All right? When I'm saying to you, don't look at how Don't look at how quickly the values go, because it's x to the fifth, it is moving exponentially. Moving exponentially. The only time I want to see things move exponentially is when me invest my money in the bank account, but it now go the way that I go the other way. All right, but to them interest rate I go exponentially, but my interest rate now go the same direction. Like funny, we're going in different trajectories. But anyhow, so we're dividing both sides. We're dividing the numerator and the denominator by the highest power in the function itself. So we're going to end up with x to the fifth over here. Look at what is happening here. X to the fourth over x to the fifth. I am going to have just 3 over x that is left. All of this 4 will take out 4 in the denominator and leave just 1. All of the 3 will take out 3 from the denominator here and leave 2. So I have x squared. All this one will take out 1 out of the 5 would leave 4. This one, they cancel out, so they have 1. This one will, all of this go into this and leave 4. So here the story. As 3 over x, 4 over x squared, this over that, and that over that tends to infinity, all of them are going to go to 0. So we're going to be left with 0 minus 0 minus 0 over 1 plus 0, which is 0 over 1. But 0 over 1 is 0. So this limit tends to 0. That limit there tends to 0. Are there any questions relating to that? Okay, I'm going to give you 5 minutes. No, I'm going to give you 3 minutes. I am telling you that this answer here is 0. I'm telling that this answer here is 0. I don't want you to look at it by inspection. I want you to work it. Work it similar to how it is that I work number 12 and number 11, which is my 12 year 11, different numbers for you. I want you to take some time in class today and work this one for me so that I can then jump to the form including the negative infinity and then jump to the past papers. Work this one for me, please. I'm giving it 3 minutes. I'm gonna hydrate and then come back. 3 minutes, please. Oh, sorry. Let me just check the chat before. All right, cool. I'm giving you 3 minutes.
Which one are we supposed to?
13.
13.
Thank you, ladies.
How are we with the stuff, guys? Are we okay?
Yes, sir.
Yes,
Very
sir.
nice. Very nice. Very nice. Very nice. Keep it up. Those of you who are just joining, please, you have to catch up. Please don't leave us. We're gonna move into some past papers after. Should I do this one? Cool, because it's just one that is left. Yeah, I need to do this one. And then, okay, that. Yeah. 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 All right. We should get up these rest today. Are we okay, guys? Still working?
Finish, sir.
All right, Coach Arlene. The others of you hurry up. Shanali, you finished?
Sir, we'll wait for you. Go to it and move on to something else.
Rockstone. Take time with me. Very nice. All right, come guys. There are 2 students who are finished.
Finish as well, sir.
All right, very nice. Okay, for those of you who are finished, I want you to start working number 14, please. Those of you who are finished, start working number 14 for me, please. Thank you. Matter of fact, Shana, Charlene, and who was that? Did you get 0 for your answer?
Yes, sir.
Good job. Good job.
I already do 14.
Yes, sir.
Good night, sir. Sorry I'm late.
Yeah, good night, Jermaine. Yes, Yannick, you did 14 also?
Yeah,
And got the answer?
yeah. Well,
All
I
right,
got
good.
an answer.
All right, good. So 14 has a trick. And I want you to, I definitely want to go through 14. So I'm just going to give you another 3 minutes just to finish off 13 and start 14. And then 3 minutes time, I'm going to do 14. I need to go through 14 to explain a difference in something. Can we say, all right? Did they, okay?
Yes, sir.
Good, good, good. All right, so you would recognize that number 13 is very similar to the one in 14. I mean, in 12. Well, my number 13 is similar to the one in number 12 that we just did. When you look here, the highest point in the numerator is 7, is x to the 7. The highest term in the denominator is x to the 8. So what we're going to be doing is dividing through everything by x to the 8. So we're going to have this goes to 0, that goes to 0, that goes to 0, this goes to 0. So we end up with 0 over 1. And our answer is going to be 0. All right? No, I didn't do this one because that is exactly the same as what we just did right up here. The one here, totally different. And we need to have a conversation about it. Some people said I got an answer. I'm not interested in the answer just yet. What I'm interested in is your consistency in how it is that we do the question, and especially the functions that contain infinity. All right. We're looking for the highest power. The highest power here is going to be x to the fourth. The highest power here is x to the third. So we're looking for the highest power, which is x to the fourth. So we are going to be dividing through every term by x to the fourth, hands down. 6x to the fourth over x to the fourth, 25x cubed over x to the fourth, negative 7x over x to the fourth, all over 4x cubed over x to the fourth, x squared over x to the fourth. This step is supposed to be very easy. Look for the highest power in both numerator and denominator. Is only one power you can divide through everything by. So when you do the division, one power, everything is going to be divided by. You can't have up here with one and then when you sit down, everything is going to have the same something. All right. This cancels, leave 6. All of this x to the third cancel with x to the fourth and leave 1x in the denominator here. So it's 25 over x. This cancels in all of this and leave 7 over x cubed. 4x cubed over 4x over x to the fourth is 4x over 4 over x rather, and this is 1 over x squared. So I've now reduced my term to 1 over x squared. Now I have it in a form where I have a constant in the numerator. I have it in a form where I have a constant in the numerator and the variable in the denominator. So what I'm going to say is, as x tends to infinity, we have 25 over x, 7 over x squared, x cubed, 4 over x, and 1 over x squared all tends to 0. So we're going to end up with 6 plus 0 minus 0 over 0 plus 0. And 6 over 0. When you put 6 over 0 in your calculator, what do you get? Math error? Math error. So once you say math error, it is undefined.
Sir.
Yes, sir.
When I finish this one, can you just go back through the first one? I want to see where I went wrong. Please.
Which first one? Which first one?
Number 13.
My number 13?
Right, yes, sir.
Oh. Ryan, look at me. This one you want me to go through?
Yes, sir.
Okay.
Sorry, come on, no one else do where I go.
I'm coming. What is the height of x to the 8? All right, so I could just do this. Just copy. All right, so you see a black box here because I'm actually typing this, the solution, Ryan, so that I can do the explanation for you. Please. Plus sign 2x squared 2x squared minus 7x to the 5th all over 4x to the 5th plus x to the 8th. And then now that and I first have that and then move it 1 over x 2 over x to the 6 7 over x cubed 4 over x to the third And this is just simply 1. And then as what now? As 1 over x, as 1 over x, 2 over x to the 6, 7 over x to the 3rd, 4 over x cubed, 10 to 0. Then I'm going to have 0 plus 0 minus 0 over 0 plus 1. No, sir, that doesn't make sense. Oh, yeah. It's number 13 I'm doing. All right, Ryan. So let's go. So let me just look out to equal 0 up here since I don't have the answer to the bottom part. So let's go. All right. So this is a given question. So I'm looking in the numerator, x to the 7th, but I look in the denominator and I'm seeing an x to the 8th. So I'm going to be using x to the 8. All right. So I'm dividing each term, x to the 7 over x to the 8, 2x squared over x to the 8, minus 7x to the 5th over x to the 8, all divided by this 4x to the 5th over x to the 8, and the x to the 8 over x to the 8. So all I'm doing here in this step is to divide through each term in the given function by the highest power. That's all I'm doing. Then the next step is to do a cancellation. X to the 7th can go into this one. X times is going to be 1 over x. X squared goes into this x to the 6 times. I'm going to have 2 over x to the 6. X to the 5th goes in here 3 times. I'm going to have negative 7 over x cubed. X to the 5th again goes into this 3 times. I'm going to have 4 over x cubed. And x into 8 divided by x into 8 is 1. Following so far, Ryan?
Yes, sir. Yes, sir.
Good. And then now, because I have my constant in the numerator and my yes, Papa, yes, Jermaine. By my variable in the denominator, right here. So as x tends to infinity, the bigger the x value go at 0, there's something going to tend to. We did that. You all know this. So we're going to have 0 plus 0 minus 0, see it right here, so over 0 plus 1. And 0 over 1 is 0. Got it?
Yes, sir.
All right. And then Jermaine asks now to go through this one more time. So what I'm saying to you is, similarly to the one we just looked at a while ago, we are looking in the numerator. We recognize that x to the 4th is the biggest one. And we're looking in the denominator. The biggest one in the denominator is x to the 3rd. I don't care. X to the 4th is going to be it. Why, sir? We're looking for the highest one. That's the reason, the highest one. Not the highest one in the numerator and then the highest one in the denominator. No deal. The highest one overall. But sir, what if both of them have the same one? Yeah, all the better. Right? But we're looking for the highest one. So it's going to be 6x to the 4th over x to the 4th plus 25x cubed over x to the 4th minus 7x over x to the 4th all over 4x to the 3rd over x to the 4th plus x squared over x to the 4th. Then the next step is to do my cancellation. You notice when I'm in the one with the infinity, the steps are so finite. So finite. You look for the highest thing, divide through the whole of the something by the highest one. Then you cancel it, and then again get something with a constant over the denominator. You say as x tends to that, all of them go to 0. You substitute the value 0 there, and what is left is going to be your answer. Finite number of steps. Watch me now. X to the 4th into x to the 4th cancels, so I'm only left with 6. 25x cubed over x to the 4th is going to be 25 over x, because the 3 x's here will cancel out with 3 of the x's, you're leaving 1. So it's 25 over x. Minus 7x over x to the 4th. And that is going to cancel and give me 7 over x cubed. Somebody unmuted to say something? Oh, all right. And then,
sorry, sir.
okay, and then I'm going to have 4x cubed over x to the fourth is going to be all of this x cubed is going to be eaten up down here and leave 1. So it's going to be 4 over x. And all of these x squareds will be eaten up. And left with x squared. So here's my story. As x tends to infinity, 25 over x, 7 over x cubed, 4 over x, 1 over x squared, all go to 0. So what I now have? 6 plus 0 minus 0 divided by 0 plus 0. That goes to 6. That is 0. 6 over 0 is undefined. Math error. Can't work. Done. Now, something came to mind when I was going through this number 14 again, and I'm forced to say it to you. Any one of you at this level gets a question like this and move from here, so straight to the answer, will get just 1 mark for the answer. You do get a mark for showing the correct division right here, so another mark for showing this right here, so another mark for making this statement here, another mark for showing this here, and another mark for your final statement. The questions normally come for 5 marks. 1, 2, 3, a piece of donut is a 4, and your answer 5. So if you give me the answer alone, best believe me, I give 1 out of 5. But sir, oh, we did do this piece in our head. No problem. Make it mark it in our head. 1 out of 5. I must see. Come on. Where am I? I must see every bit of working out in order for full marks to be awarded. Please. Very important. I can't overemphasize that fact.
Sir, so I must put the undefined to on it. Get a mark.
Yes, ma'am. You have to put, yeah. So put, you put 6 over 0. If I'm in a good mood, I give you the full marks, but I want you to recognize that 6 over 0 is undefined. 0 over 6 is 0, but 6 over 0. Once you have a 0 in the denominator, it's undefined. And I want you to, at this level, you're supposed to know that. At this level, you're supposed to know that. Yes.
So, time is going to be against us, so we're not going to get to put it. So just be nice to it.
Sasha, leave me alone. I love you too, Sash. But you're gonna put it here now, Sash. You're gonna put it. All right. So Sash just segued us into a lovely area, which is pretty much the same thing. So I'm not spending a lot of time on this because I want to do this and then just break into some past papers and then just move on into something else. All right. So come, Sash, back at you now. So we've been looking at positive infinity, but sometimes they will say to you that the function tends to negative infinity. Oh Jesus, sir, that means you have to do the opposite to it? No, man, are the same something we do. But watch this here. Negative infinity, and this is the only difference, and I want you to be able to recognize what is happening here. Negative infinity. When I raise a number, a negative number, when I raise a negative number to an even number, and I raise a negative number to an even number, the answer is positive. When I raise a negative number to an even number, the answer is positive. When I raise a negative number to an odd number, the answer is negative. X to the first is an odd number. So this x here is going to be a negative infinity times a negative 7. So this term is going to become positive. So this term will be positive. This is a negative term. But x to the third cannot compete with x to the fourth. So up here, so is going to be positive infinity. Everybody see that?
No, sir. Can you repeat that, please?
Sir, I want to go in at the front line. Come back to the local.
All right. Okay. I want to just fly to China a while ago. Let's go. Do me a favor. What is negative 2 raised to the second power?
Negative 4, sir.
And that's why I said, you know, and I said to myself, I said, Sean, you actually answered that question in my class tonight. Very nice. And that's why I said, a while ago, you know. They say any calculator that you use that give negative 4, that calculator is cheap.
That's supposed to be 4, right?
It's supposed to be 4. So what you need to do for those with the cheap calculators, please to put my negative number in parentheses, in brackets. So let's go again.
Sir, that's why I recommend a good calculator at the end of the class.
Absolutely, Lexton. Absolutely, because I don't want no more cheap calculator in my class. So do for me now, guys.
Feel bad.
Open. Never mind, Sash. Today's speak committee. Open your parentheses for me. Open your parentheses. Put in your negative 2. Close your parentheses. Square it, and then you will get your positive 4.
Yes, it now.
Yeah, man. Do the same thing, but raise it to an odd number, like 3, 5, 7, 9, 11, 13, you name it. Raise it to any odd number and say if the answer is positive or negative. What do you get?
Sir.
Negative.
Negative. All right. So you see what I'm saying to you? This one says limits and theorems. What is a theorem? I am proving to you that this is a chicken. So you can now move on and know that it's a chicken and you don't have to prove it because you are not, we have already proven these things to you in class, so you can go ahead and use them. So I spoke about one theorem, well, I spoke about several theorems tonight, right? Like when I give you some laws of indices. And here goes another one. When I raise a negative number to an even power, my answer is positive. When I raise a negative number to an odd power, my answer is negative. So I'm saying to you, when I put in negative infinity, cube is going to be a negative number. And a negative number times a positive number is a negative number. So this term here is negative. You know, I like teacher and students understanding. I don't know. Teaching is, I guess, my calling, because as I'm teaching, ideas just keep flowing, but guess what? I don't know how to do it. All right. How do I get this?
Let the Lord direct you, sir.
Yeah, and absolutely, he is always a director. I'm trying to write something on this thing so that you can see, but it is eluding me right here. Say, Yannick, say it again, honey.
Share what you're trying to do with the saints and see if we can help you out.
Oh, you know, the only thing about it, you know, is that the saints don't know this software that I'm using. I cannot find it out now, though. Thanks to negative. And then this term is going to give me, it's going to become positive. And then this term is going to be positive. And then you know what I'm going to do? I put that one on the other side of things to say negative. And then put the other side to say positive. All right, watch this now. And I hope I didn't confuse anybody by doing this. So this term, this 6x to the fourth, is going to become a positive term. So why positive again? Because when I raise a negative number to an even power, it is positive. And positive number times 6 is going to give me a positive number. Can everybody see this positive up here, sir?
So you have to write that in the little jottings, them the colored jottings when they get the chart.
I see the pattern coming on, sir.
Nice. Nice. Oh dear, no, not that. Yeah. All right, let me just do this thing here because I want you to get this. So, no, hear me out. No, not because I come to class and I help you to write your notes and I'm going to take my notes and sit down there and make it gather dust. If I find that that is happening, and I can find out, I can find out. If I find that what I am doing here, when I'm going to sit down on it and make it gather dust, best believe that I'm going to start come to class more often than not and write. So you have to show me that what it is that I'm doing, you are appreciative of it by trying to absorb the information on paper or on screen. All right? It's just a warning. So note, when you raise a negative number to an even power, the result is positive. Conversely, when you raise a negative number to an odd power, the result is negative. So, Carlito, when you have this information, you know what? Nothing else, because you know exactly what sir to write up here. So now, eh?
Yes, sir. Thank you very much.
Bless your heart. You can just pay me a curry lobster afterwards. All right, let's go. So this is what is going to happen here now. This is an even number, so this term is going to be positive. This is an odd number, it is negative. This is an, oh no, right, watch me now. So this is an odd number, let me fix it properly. I'm correct, but let me fix it. It's an odd number, so it's going to be negative, but let me do the right thing, because I don't want anybody to copy and paste. All right, so look at what is happening. So it is a negative number, but this negative number multiplied by this negative number gives me a
Positive.
positive. Right, it's going to give me a positive number. But let me just, since I put this statement right here, so I want it to be consistent. So when you're revising, you can see the consistency. So this negative number times this negative number will give me a positive number. And this here is going to be negative because it's x cubed, and this is going to be positive. What I'm saying to you here, this positive in the denominator is a bigger number. Sir, how you know that? Because this is x to the fourth. This is x to the fourth. And this is only x to the third. It doesn't matter if it multiplies by a million. It is still the power. Remember I told you about the exponential raising of the stuff. So this term is still going to be smaller than this term. So I'm still going to have a positive infinity. This term is positive. This term eventually becomes positive. But let us not even look at the other terms. Let us not even look at this term. This term is x to the fourth. This is only x to the third. So this term by far is a bigger number than this term. So this term box this out of the way. And then these two terms will become positive. But I have another positive term here now when I multiply these two negative numbers. So up here says it's going to be even more positive. So you can understand when I have positive over positive now?
Yes, sir.
Yes, sir.
Good job.
Yes, sir.
Nice. Nice. Sean Anderson, are you understanding?
Yes, sir. Yes, sir.
Sherry, you understanding?
Yes, sir.
Good. Krishna, are you understanding?
Not everything, sir, but I'll get there.
Unacceptable. What you
Man,
not understand it
no,
no,
man, sir, it's my first class, so
So
I have
Krishna,
to.
yeah, but let me know, let me know, let me know so that I can find other ways to fast track it, because you see what is happening, Krishna. And let me just pause and say it. I think Yannick said something I was going to say to Yannick, but I'm so happy that somebody else comes say, Yannick, don't think that I'm attacking her. I love my students. I treat all my students the very same way. So Yannick was saying to me, sir, I wasn't at class the last time. No, we see when you miss a Shan class, John knows that you miss enough. And I know things are going to come up where it is that you can't come to all the classes. And I take blame for it. And that's why I didn't respond to Yannick, because I had copied the notes and I thought I sent it off, and I know I uploaded the thing to the YouTube thing, but I've just not seen it on my phone. When class finishes, I'm going to look at it and I'm sure I'm going to find it. I'm positive that it is there and it is still private, and I just need to make it public for you to see it. And as soon as I get this on, so I have 2 recordings to send off. So maybe if I'd sent off the recording before, Yannick would have seen it and caught up. What I'm saying to you, Krishna, is that I know you just started class. I may not have gotten a chance to get the notes, but you have to try and understand this, because if you don't understand this, you're going to have all of last week and all of this week work outstanding, as opposed to have only last week plus Tuesday. So you don't have to go through today because you don't understand today. So that's what I'm saying to you. Stop me and let me know.
Yes,
Make
sir,
me
I
tell you,
understand.
yeah, make me tell you, Christian, you ask so much question, man. Talk to me outside of class, and I won't say that. I will never ever say that. Right? I would either send you a direct message to say, here the plan, Papa. Just relax yourself. Me and you will have a little one call. But I want to hear from you, please.
Okay,
Yeah, man.
sir.
Bless up. And because who else I can interfere with now? I know you're understanding. I know you're understanding. Zidane, are you understanding?
Yes, sir.
All right, please. Okay. So intermittently, you'll see me stop my class and ask students. This is 2 weeks now, and I believe that I have created an environment for you to feel comfortable enough to stop me and ask me, sir, go over this one, please. I'm really not following. I don't want anybody to leave my class and not do very well. Funny story. I had calls. Mrs. Campbell sent me something to check on something the other day, and calculus scores, and I had to look at some grades for the calculus one. And when I looked at it, I recognized how beautifully the students performed, how beautifully they performed, and may have the same expectations of Uno. Anybody get a C minus? Anybody get a B minus if I go over the course? Yes, Ryan.
If I will go for B minus. B
Clearly.
minus, sir.
Oh.
All right.
Yes, sir.
One more time. Let me say it one more time, Jeremy. Let me say it one more time. Let me
That
say it
now
one more
right,
time.
sir.
Eh?
Now see me look back.
If you do for C, you can get B. Hear me out. Anybody get a B minus if I do over the course? All of you sitting right here have the potential of getting B pluses into your A's. Real talk.
I pray Edicus of work with me.
Sasha, you know, you just a cramp myself.
And they say there's something different about Edicus so that it is 3 and then.
Jermaine, get off the phone. All right, let's go. All right. So, all right. So, Selvita, you see what is happening right there now. So I made that notation for you, hon, and I'm sure. By the way, I hope you feel better today. I should have asked you that at the start of the class. My bad. You right here, you see what it is that I would have done in order to get this piece right up here. So, all right. Now, watch me. The same something that I would have done with the positive infinity, indeterminate form, including positive infinity, is the same something I'm going to do with the indeterminate form, including the negative infinity. Look for the highest something up here, so, and down here, so, and to divide through everything by the highest one. Now, x to the fourth is in both numerator and denominator. So it's going to be x to the fourth, 6x to the fourth over x to the fourth, 25x cubed over x to the fourth, negative 7 over x to the fourth, 4x cubed over x to the fourth, x to the fourth over x to the fourth. Sir, then what's the difference? One is just negative infinity, so you have to just be careful to see if the terms will work out to be negative or it work out to be positive. All right, watch me now. Them two you cancel, leave 6. The x cubed canceling x to the fourth and just leave 1x under the denominator. The one up here, so go in the one down here, so, and leave x cubed. The one going to one here, and just you only leave x. And them two you cancel and leave all of that. The same song that we're singing to and dancing to. 25 over x, 7 over x cubed, 4 over x, all tend to 0 when x tends to negative infinity. Sir, but you just said to we say, this, all of these tend to 0 when it tends to positive infinity. Then, sir, it tends to 0 to when it goes negative infinity. Sir, I don't understand that. Take out the calculator for me, please. And put in there 25 divided by negative 1,000,000 and tell me what you get.
Zero.
0? Or did it say negative 0?
0, sir.
0, don't. I think so too. Anybody disagree? Somebody else try, please.
So,
Hmm?
so what you say we must divide 25 by negative 1,000,000?
Negative 1,000,000 or negative not 0.
Sir, I'm not getting a 0, you know.
Where you get a lie, I tell you now. I bet you see something times 10 to the negative something up there, don't?
Yeah.
Yeah, a 0, you know.
2.5 times 10 to the negative 5.
Yeah, man. Charles.
Yes, sir.
You know, so a 0, you know. So it's going to be negative. Wait, do divide by 1,000,000. So I'm what it be. It's going to be negative 0.00000000009 zeros, then a 2 and a 5.
Oh.
Yeah, man. So that exponential, the standard form is that thing there. So you have to be careful of that. So negative 0, the same thing as 0. Somebody answer me.
0.
Yeah. So Charlene just said she get 2.5 times negative 2.5.
Undefined.
No, undefined. So we get a number, undefined. So Charlene, so we get negative 2.5 times 10 to the negative no. Is that 0?
Yes, sir.
It is 0.
Yes, basically equivalent to 0.
It is 0. It is 0. So I'm just showing you because I don't want anybody to go and create any mathematics. I want you to see that it works. So it's 0, 0, 0, 0, 0. And then we have 6 over 1, which is equal to 6. So as it tends to negative infinity, that function tends to 6. Fair enough? There are some other questions that we need to look at. So you see, if it's a negative infinity over negative infinity, it is still indeterminate. If it's a positive infinity over positive infinity, it's still indeterminate. If you say 0 over 0, it's indeterminate. All right, that's what I want you to get into that. All right, so I think I spent enough time on this. I think I spent enough time, and I think I just asked if you guys are understanding. So I need to move on to the limit of a constant. I'm not going to do that yet. What time is it now? 10 past. Do me a favor. Let's go to our cell phones. Let's go to our Let's go. Which one should we do first? Let's go to the first setup, the first past paper that is in the group. Oh Lord, I should put all of these in one place. Now we're going to have so many pages to go through with this stuff. I need to remind myself that the past paper came, the first one that Ryan sent, 2018. 2018. This is one of the things about me, students. When whatever course I teach, past papers must be a part of my class. I don't just work past papers at the end of the class. So we work past papers throughout the session. All right. So work with me now. Question 1A, it says evaluate the following limits. One for 2 marks, one for 3 marks, one for 5 marks. So you get 3 questions for 10 marks. And then we don't reach anywhere else yet on the past papers.
Sir, if I work it out like 16, we're going to get full marks because that way fast. So,
when it says 16, what do you mean? For which one?
Number 16. Number 16.
If I work it out like how I have it here?
Yeah.
No. I'm only doing this here for teaching purposes, you know. So what I don't want to do when I do my stuff, Sean, I don't. You notice a while ago when Ryan asked me to work number 13, I had to go and copy and do the question because all I did was to put a 0, because that would have been, whenever you see the question looking like that without me fully working the question, it means it is a class activity. If you follow what I'm saying. All right, so this one here was a class activity for you to do, but because he asked me to go through it and I can't write on a board, I went ahead and did the solution, right? But now this one here, as I would have had it here, would have been a class activity for the students to do, and I only put the answer there. All right?
All right, sure.
Good. All right, so let me stop share. No, I shouldn't. Let me go back. All right, do me a favor. I'm giving you. Are you all at the same question?
Yes, sir.
All right. There are 3 questions.
So which question?
2018, Tuesday, December 4, 2018.
I forwarded it in the group again. So
right, thank you. So question 1A we're looking at. I want you all to do 1A. Now, guess what? I will call upon somebody. You don't know which somebody I'm going to call upon. I don't want nobody to sit down in my class for their pretty looks. You all are to be working. Well, Sean won't be here for much, but you all will be working. All right? So please, none of you sit down and not work. You have 3 questions in front of you, and I'm expecting an attempt. I'm not asking you to get the question right. I just want an attempt so that when we go through the question, you can see what is happening. I make a special effort to do past papers within our class setting so that I can set questions for you so we can come to class with them. All right, 5 minutes, 6 minutes. Just to let you know that I'm still here. Are you all okay?
Yes, sir.
Very nice. What about
So
the rest
far,
of
so
you?
good.
Very nice. Love to hear that. Yellow. Class silent. I'm sitting here and I'm like,
X4.
X4? What are you talking about? X4 or X to the fourth power? What are you talking about? What is up for the answer? Anybody got the first answer? What did you get?
Sir, for the first answer.
First answer 5.
5, sir.
5.
5, sir. Okay. Aviana, what you get? Karika, Jermaine, Lexton.
Strong. 5.
5. Very good.
Sir, I'm good
Anika.
at this, sir.
Nice. Anika, talk to teacher. Sean Anderson, Zidane, Unique. Shani,
Sir, 5.
you say 5? All right. Let me check to see if I'm right. Tum 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 tum. Blow. Whoa. One are shot in. All right. Was this the second question?
Yes,
Right,
sir.
can you hear me?
I can hear you, Sean.
Yes.
You got 5 for the first one?
Yes,
Yeah,
sir.
look at
Yes, sir.
second one.
You look at the second one. What do you got for the answer for the second one?
0.
Sir, I got
1.
Sir, me get 3 over something.
I got
Negative
3 over
-3/7.
-7.
-3/7.
Negative 3/7?
Yes.
7. Yes,
Okay,
sir. That's
Abby.
Over negative
Yeah.
7 that me have.
Okay.
Yes, sir. 3 -7.
3 over negative 7 the answer.
Same difference. 3 over -7, negative 3 over 7, negative 3 sevenths.
Yeah.
As long as you have the negative sign there. Everybody good with that so far?
Yes, sir.
Yes, sir.
Very nice. Just a little worried. Davia.
Sir?
Sir, number 3 kind of long, you know.
Number 3 did have me aware.
Number 3. I got number 3. I got 0 over 0.
Number 3 is 0.
0.
Number
Defined.
No, but all of you wrong. Number 3 is not 0.
Terminate. So you have to
Sir, me still have number 3.
You have to factorize it. Number 3, sir, after my work some magic.
Sir, me still have factorize it.
You still have factorized? Krishna! We're not leaving you. Charlie, what are you for number 3?
Sir, I'm still at work on the factorization part, sir. I'm still right.
Factorization.
Sir, I feel like I do some scamming, you know. But
well, I didn't know that about you long time, you know, Yannick, but I never want to say it, you know. Yannick, the popo will come for you. The popo will come for you.
in the act. Them have to catch me in the act.
I true that.
Hold on there. I'm a 0.
You know, I never get 0.
Sir, you sure?
Sir, you're sure, sir? You get
Yeah,
0
positive.
undefined.
0
Undeterminate.
over 0 is indeterminate.
Yes,
Oh,
that I put indeterminate.
You know, but I'm not get it.
But when you get that,
Tell me why I'm not get it.
Sir, you know work it out.
In my headspace, I thought I did the question, you know. Jano, hey, what, Sash? What is happening to your teacher?
why?
Too much rum.
No,
Sir, you know what go on? I can't tell you what go on, you know, sir.
What go on?
You never something about the factorization and they plan for teach it, but you never teach it, so you never work it out because you never plan to do it this evening.
Well, actually, no.
That's my story, and that's what I'm sticking with,
I'm
sir.
sticking to it. Okay, Yannick, all right. So guess what happened now? So I actually did the question and I was supposed to type it, and I honestly thought I typed it. The answer is actually 0 for true, but I was just saying no because I want you guys to think about it. But yeah, so I actually did the question, but I didn't type it. No, but Miss Yannick, I did factorization with Uno, so it's my story, and I'm gonna stick to it.
No, sir, no, not that matter, but there's a special thing about the factorization.
Okay, got you. Yeah, and that is so true because this one here is known as a perfect squares. Yes.
Yes, a perfect square.
A perfect squares. Yeah, I actually did it, but I didn't type it.
The x squared, the denominator, by the way.
Don't worry about it. X squared plus 6x plus 9 over x squared plus 3x.
Then we know not that one, but we get 0 from our answer. So may I wait for the solution there.
You know, say,
Yeah, you say you
you know,
reach
it-
there. You're
it-
not sure how you reach there, but you reach there.
You know, so she sound like this camera, you know. Talk through.
It looks so, sir. It looks so.
All right. So when I went through the past papers, thanks again, Ryan. When I went through the past papers, I'm just very lazy, so I'm just gonna just copy something I tell you before. When I went through the past papers, I felt so encouraged that I'm saying to myself, you know, look at this. This is really not difficult. And I said to myself, let us start working these questions. So I actually typed the 5 and the 3 over 7 and was supposed to be typing the other one, but guess what? I was in a meeting today from 10 o'clock until about 3 o'clock. And I was sitting up and then I get very tired and then I go lay down and I said, but wait, I have my calculus 1 exam paper to write. So I started writing your exam paper and almost finished it as a matter of fact.
Sir, you're wicked. You can't do that already. You're wicked.
The
But
blood.
sir, you're supposed to do a right word the answer
Sir,
to the
wicked.
sir, you are prepared for the end now. We are trying to enter the journey. No, sir.
So
All right.
I got distracted.
Sir, you need some coconut water.
Yeah, I want to talk truth. I got distracted, so I said to
need
myself,
to
you
wash
know,
off, man, sir.
no man, you're good,
That's for
man.
the coconut water last week, so that's why that's why.
Hey, oh yes, it's true. Yeah, man.
That's
It was,
why
yeah, it's
gone,
true.
so.
No man, I have to make sure so I have to take care of one also. While my other colleagues are complaining about this long meeting, one of them called me and said, "You are Lottie. I am doing my work. Multiply the coefficient of x squared by the constant. 1 times 9 is 9. I need 2 numbers. When multiplied together, will give me 9, but when added, give me 6. It's going to be 3 and 3. So I'm going to have x squared plus 3x plus 3x plus 9. And then I'm going to have x plus 3 times x plus 3. And then I'm going to have x plus 3 times x plus 3. So this is known as a perfect square. This is known as a PERFECT, perfect SQUARE. It's known as a perfect square. All right, so what I'm going to be doing now is placing that there. X plus 3 times x plus 3, x plus 3, x plus 3 in one bracket there, times it by something right there. And if you look at the denominator, you recognize that an x is common to the denominator, true or false?
Yes, sir.
True.
So I can factor out an x in the denominator. So when I do that, I then recognize now that one of the x plus 3's in the numerator cancels with one of the x plus 3's in the denominator. Oh no, undo. In the denominator. And then I'm going to be left with this.
You get 0 over 3.
0 over 3. No, 0 over negative 3.
Negative 3. Yeah, negative 3. Yeah. That math, sir.
Mm-hmm. Equals 0 over negative 3, which is equals to 0. Guys, I'm very.
That way.
You didn't do it. Oh, yeah, what way did you do it?
Sir, I did not factorize the denominator. So I substitute the -3 and get -3 square. So yeah, and then I get the 9 and then plus 3 times the -3 would that give me, would that change it to 9 minus 9, would that give me 0/0?
Yeah, that's the first step.
That's the first step. Yeah, man, that's the first step, honey. You're correct. That's the first step. It's just that teacher never write the first step because teacher, you know, question fast. So, yeah, man, you're correct, my bunches.
Sir, so the schema thing with me do
Mm-hmm.
is me stop after the group, the first line of the grouping.
X plus 3.
And then cancel and then use the 2x plus 3x, the x squared plus the 3x to cancel the bottom one.
That's illegal.
Sorry, that is why it's a schema way.
Yeah.
I literally said
And if the popo, in another class of popo, we arrest you.
Sorry, it appears that way. It could just use the replace the -3 with the x and just wrote it out.
And then you can get indeterminate. That's what they said a while ago. So if you don't, yeah, man, you remember who was it?
Right away, right?
All right, somebody just said a while ago that, sir, I did it different. I went ahead and just put the -3 in the stuff. If you put -3 squares is going to be 9, and 3 times -6 is -18. This 9 plus this 9 is +18, minus 18 is 0. -3 squares is 9. 9 minus 9 is 0. So if you substitute it, you will get indeterminate. So now that you know, that it's indeterminate, you have to do one of 3 things: factorization, simplification, or rationalization.
Sir, me figure out what I do wrong. Can't count.
So after you do that, you have to basically do the factorization thing after.
Okay. So you have to recall those 3 little secrets. So once you get indeterminate, there are 3 little things that we have to go: factorization, rationalization, or simplification. And when you look at this stuff, you recognize it can be factorized. So if when you do the question and you get 0/0 and leave it right here, say, don't you get 1 mark? I don't even give 1 mark for this. Because you should know that once it is of the indeterminate form, you have to go further to do something else. It's very important.
Sir, not even 1 mark?
Say it again?
Not even 1 mark?
Not even, Shan, not even 1 mark. This is big school mathematics.
I just stop on sir, right?
Right to say stop?
Yeah.
Sir, go down,
You're the
scroll
weakest
down a
link.
bit, sir.
As usual, you know, say, what's on my thing?
Jermaine, stop that foolishness, please.
Yeah, hold on there. Scroll
back up, sir. Scroll back up a little bit.
Sir, isn't it x squared that was under the denominator?
Yeah, there's x squared plus 3x in the denominator, and what I did was to factorize it to give me x times x plus 3.
Sir, go back up and see that statement there. Sir, so that statement there, after right? Right there.
I wrote it causing to say, where am I? I wrote it because I want you to see what is happening. I don't have to write this, you know. I wrote this because Jermaine saying want to stop right here, so this is of the indeterminate form. So I'm now saying to you, recall the 3 little secrets: factorization, simplification, and the other one.
So you said form, you have from.
I want to put that there to see if you're paying attention.
Right.
Oh, Jesus. All right, we have around about 17 minutes left. I hope you're not tired. I have to introduce.
Hold on a little bit, sir. Please.
I have to introduce my piecewise function. See the piece out here, so I have to introduce my piecewise function. And actually, I'm at number page 12, but I just need to introduce a piecewise function. Just have a conversation about it, and then that's where that's our starting point for Tuesday, all being well.
So, sir.
Yes, son.
The square root thing that I see a glimpse on your page, it is basically what we just did. You don't have to go through that.
This?
Yeah.
Mm.
No, I saw it somewhere else.
Oh yeah. You're right. Boy, you had them goodie, man.
In
Jesus,
I notes.
Jesus, Father.
Yes.
Oh, you had them good, Sash?
Sure. Me just see the square root and then me come.
Sash, your police don't.
No.
Yes, man. You know, it's all right, man. You have to have some connections, Sash. Yeah, man. But you're right, though. Yeah, the square root sign is there. And I'm happy that you asked that, Sash, because what I try to do when I'm preparing my notes is to find varying questions, and that's why past papers are very important in my whole teaching and learning.
Go back up to
In my whole teaching and learning, because you actually get such an idea as to not just how I write the questions, but how other lecturers from other community colleges will write the question, right? So that's why, and it does not go for math alone. So any course at all you're doing, get your past papers. You will thank me later. Get your past papers. Let it be a part of your daily routine. Get your past papers and start working. Matter of fact, I wanted to have done 2 sets of questions on the past papers tonight, but let us just agree that we're going to do the questions in order. So since we do the limits question for this paper, let us take the other paper, the second paper that Ryan sent in the group,
And do the limits on that.
and do the limits on that in preparation for next class. So while you have homework, I will have homework. You know why? Because I don't want to come to class and read. I mean, even though I think I move fast enough with the system, but I really want to just come and just present it to say, boy, this is it. So I won't necessarily say to you, post it in the group so we can mark it. No. But I really want you to be doing the questions. Get into the habit. Okay, let's go. We have 40 minutes. Piecewise function. Now I'm going to ask that you stretch a little. I know it's nighttime, but guess what? Oh, Rockstone. You see, the end of this. It's the end of this sojourn. The end of this sojourn, you're going to be looking back and thanking God that you survived. And you're going to look at times and you feel like you couldn't make it, but you can push through. And my responsibility is to encourage you. The failing students I must encourage so that you can get over that threshold. All right? Watch me. So stretch. Don't even think about you wanting to sleep. Some of you want to sleep, but that's not a part of it. You have 50 more minutes to go. Watch me. Piecewise function. When you hear piecewise, Jermaine, don't answer it because I know your piecewise is different what we're talking about. Piecewise. Let us get the Christian definition of piecewise. So when you hear piecewise, wait, what are you thinking? What comes to mind?
Everything even, sir.
Everything even. All right. Anybody or somebody? Wait, are gonna leave me?
We all put it to Christianity. We have nothing to say.
So that means you're going to
everything and smoke it.
So your response would have been that something that was unchristian, like, okay, piecewise. It means that I'm going to be working these questions piece by piece. All right, piece by piece. So I can't work the question in isolation. One question depends on the other question, which depends on the other question. So we're talking about one question. So we're going to work 3 questions one time. Okay, let's go. So the question says, determine if f of x is continuous at x equals -2 and x equals +2. Given that f of x is this below, oh, sir. So this is one function? Yeah, one function with 3 functions into it. So you have one hand with 4 fingers and a thumb. So you have one function with 3 something them to it. So don't lose me. Don't lose me. Let's go. So the question says at x equals -2, at x equals -2. So I have it here at x equals -2. Now, so remember when we were looking at the intuitive approach, we said when we're looking at -2, we're going to be looking to the left and the right of -2. Talk truth.
Yes, sir.
Yes, sir.
Come on. So we're looking to the left of -2, looking to the right of -2. In this here case, and I did say to you that we're going to come back to that concept, but in this here case, we're not going to go to -1.9. negative 1.99, and then negative 2.1, 2.01, and 2.1, and then 2.01. No, we're looking to the left and right because the piecewise function. Look at these here. Watch me. This is what we're talking about. So we're looking at x equals negative 2. And una calculus students, una do BMIS and BIT and them sitting there and them only for something make you do. Watch me. X equals negative 2. Can I at any point in time look at this line down here? So
Wait, sir, if x equals to negative 2.
it says x equals negative 2. Why no? Why no?
X
Because
equals
S is not greater
Greater than
than
or
or
less.
equal to 2.
Because this is not negative 2, don't it?
Yeah.
Right.
All right. So I am showing you how to eliminate some things. You don't make some mistakes. Some mistakes in life you don't make. They are out there. Catch somebody else, not you. So we're not even looking at this. Why, sir? Because it says negative 2, that one is positive 2. We must look on the one you don't.
Yes, sir.
And we have to look on the one here too, because the one here is a combined something, but it have negative 2 in here. So right up, we know, so we now look on this. But here the story now. Story time. So sir says, when we're looking at x equals negative 2, we have to look at both the left-hand side of negative 2 as well as the right-hand side of negative 2. Now watch me. X is less than negative 2. Less than is to the left. Talk truth.
Yes. True.
All right. And watch this story now. Shh, don't talk. Secret. X is greater than negative 2, but x is less than or equal to 2. Watch me again. X is greater than negative 2, but x is less than or equal to 2.
So greater than or equal, right?
Huh?
You understand sign that?
Uh-huh. All right, come German, come German, come German. You look on something else in a German at this moment. You look on in a German, let's go. X is less than negative 2. So because it is less than, we're looking to the left of negative 2. So this one here is to the left of negative 2. Watch me. X is tending to the left of negative 2. Remember the little minus up here, so talk about to the left of, don't it? I introduced it to this before. So to the left of negative 2 is going to be the function 2x minus 1. So I'm going to write 2x minus 1 here. So, and then now because we're using the calculations approach, the only time you use the intuitive approach, guys, is unless I tell you to use the intuitive approach. So because we have this function here now, we're trying to find the limit at x equals negative 2. We are going to assume that x here is negative 2. Watch me. Putting negative 2 into it. I'm putting negative 2 into it. And I'm going to get out something else. When I put in negative 2, it's going to be negative 2 times positive 2, which gives me negative 4. And negative 4 minus 1 gives me negative 5. So you're putting in this negative 2. Negative 2 times 2 is negative 4. Negative 4 minus 1 is negative 5. All right? So to the left of negative 2, we have to look on the function. Them sign here tell you if I left and right. All right? Now watch me now. Come back to you, Jermaine. This one says we're reading inside out. We got to work it from the inside. Working it from the inside. So we catch the x right here, so. And then we're going to move to the left and work it. Then we catch by the x right here, so. And move to the right and work it. So in the middle, and we are work it. Reading from left, reading to right. Reading from left, reading to right. Whenever you catch this double integration, double inequality, we got to work it from the inside out. We catch it from the inside, work it out. We catch it from the inside, work it out. Catch it from the inside, work it to the left. Catch it from the inside, work it to the right. All right? Now let's go. This is x is greater than, you see it up now? So it's greater than negative 2. You see it close up? So x is less than, but it have one little something underneath it. So we have to call it equal, less than or equal to 2. So that means this piece here, x minus 3, is to the right of negative 2. Sir, oh, you know it's to the right of negative 2. See it, so it says x is greater than. Greater than is to the right, less than is to the left. Less for L, left for L. You can't mix up the left hand and the less than, you know. The less than is to the left, and the other one have to be to the right. Watch me now. So I'm going to use the x minus 3. See x minus 3, and I put in the x here and a minus in 3, so I get minus 5. Now the mere fact said that 1 here equals the 1 here. But sir, you did tell me this before. Yes. So the limit is of a good behavior because the limit to the left is equal to the limit to the right. Sometimes when I teach, I want you to see what is happening. See here? So we say that it's of a good behavior since the limit approaches 1 from the left and 1 from the right. See here? From the left, from the right. See here? From the left, from the right. It's just that whenever they show you another way of writing from the left to the right. Here goes a grown-up way. This is the grown-up way. Come on. The limit as x tends to -2, the minus sign means to the left and the positive sign means to the right. So the left and the right are equal. So we say that the function is continuous at x equals -2. So we don't need to check the function if it's going continuous at x equals +2. Work with me. Can I use this at all? Answer. Can I use that equation at all? That
No,
function at
sir.
all?
No,
Why?
sir.
Why?
Less than -2, sir.
No, because I want to have negative sign. We just want a positive now. So the one you have +2 and the one you have +2. So we know, so you cannot make mistake and use this one again. Because this one say x is something with -2. It's not -2, we're on to +2. So let us go. Let me do this. Crunch it. Now, hear what it's saying. I have a notation here. I have a notation. Note. To the left means less than. It's only a go school teaching and giving them niceness here now. And to the right means greater than. Stop. Think back to the number line. You have your number line. Less than is over the side here, don't it?
Yes, sir.
Yeah, man. So that'll be to the left of the number line. Greater than is over here, so it's to the right. Talk truth.
Yeah, sure.
All right, good. Now, that's something here, Jermaine, is read x is greater than 2 and x is less than or equals to 2. You have to start at x and read to the left, go back at x and read to the right. You cross the road when a little bit, you have to look to the left, you look to the right, and them say look to the left again. But to me, they're smarter than them. Me look to the left, then the right, and me look left and right again. Because when me look to the left, it can't come to the right. So me look to the left, the right, and then left and right. All right? So when you're reading your inequalities, x is greater than -2, but x is less than or equals to +2. So here my statement. Since the limit, the one here, 2x minus 1, is equal to the other limit, x minus 3, then f is continuous at x equals -2. X is continuous that equals -2. All right? Now, let me just put my please note down here. So, guys, it's a woody for something to go through tonight, you know. Trust me. Now, I won't go through these. I'll give you that as well. Yes, honey.
Sorry, you say you're going to go through this to start next class again, right?
Yeah, man. So I'm just gonna do this.
I'm gonna my brain absorb it yet.
No, man, don't worry about it. I'm gonna do this piece, this last piece here, and I'm ending class at this last piece, but I don't have a problem to just run through this piece again and this piece so that you can see it. What I want to do is to give you some information in preparation for next class, so you know exactly where I'm going to start. So when I send you this the handout here and the what do you call it, the recording, I'm hoping that you guys will do your preparation so that you're all not rusty for the next class, so we can get a good start, a jump start in the race. Let's go. So, but I did some work on this thing and put the word at. I'm sure I put the word at. See, here's on this. I'll put it, you know. Something wrong with me, I need to get a vacation. I never take no break from summer school right back into semester 1. John, no. Sure. All right. Okay. So we're moving at x equals. All right. So it's continuous. So we're moving at x equals 2 now. So we're looking at the function at x equals 2. So we're looking to the left of x equals 2. Watch it. x is less than or equals to 2. So this is to the left of negative 2, of positive 2. So to the left of positive 2 is going to be x minus 3. See here? The left of negative 2, of positive 2, I'm sorry, is going to be x minus 3. So we're using the calculations approach again. Sorry. So it's anywhere in the function I see x, I'm going to put 2 minus 3. And 2 minus 3 is negative 1. All right? And then now to the right, x is greater than is going to be x minus 1. To the right is going to be x minus 1. So anywhere in the function, see here, x tends to 2 to the right. Remember, the superscript plus is to the right. The superscript minus is to the left. So I'm looking at the function x minus 1. Anywhere in the function I see x, I'm going to put 2. So it becomes 2 minus 1, which is 1. But the one here negative 1 and the one here positive 1. Watch my statement. Since the limit to the left is not equal to the limit to the right, then f of x is discontinuous at x equals 2. And that's the end of the class. Right at 10 o'clock on the dot. So for the piecewise function, the left-hand side limit must be equal to the right-hand side limit for the function to be continuous. If the left-hand side limit is not equal to the right-hand side limit, then we say that the function is discontinuous. All right. The other thing to remember, we're reading inside out. We start at x and read to the left, and then we read to the right. To the right is positive, or it's greater than. To the left, to the right is positive and greater than. To the left is negative and less than. All right. The other thing that we looked at here is that I can give you a function. Let me just show you some other examples that you'll do for me at some other time. This other example here that I have for do now, you get 3 functions right here. So the one I have only 2. Did I do 1? That one has 3. That one has 2. But you can get something with a function without 4 things in there. Don't have to worry about it, right? Because this is where I want to go. I want to build up into continuity. So that's what I'm building on. So we talk about continuous functions. So that's what I'm building on. All right. I'm going to stop here. But I'm going to say to you that it was a productive class on my end because I got to where I want to get to. Plus, with putting a past paper, if you're working something there, bite-sized steps. At the end of the day, you will have all these answers to your past papers that we would have been doing. So when it's the end of the semester, nobody says, "Sir, can we work past papers?" We would have worked those already. So I will have a conversation with you in the WhatsApp group. And please let me just give you a nod up. If I say that I'm going to send you something and you don't see it, just send me a gentle reminder, please. I have a whole lot of things I'm trying to do. I know you have a lot of things to, but sometimes like what I did here, I actually cut and paste what it is that I wanted to send you, and I know I did it, and then it's afterwards I found it on the computer in the unsent form, and I proved it to you that I'd done it before. So if I promise that I'm going to send something, just send me a gentle reminder. Don't send it tonight and say, "Sorry, 2 hours gone." It's late night, but for sure by Friday evening, Saturday morning, you don't see it. Send me a gentle reminder. Say, "Sir, remember the thing, please." Don't rush me and say, "Sorry, you see, I'm going to send you something, I don't send it yet." No, me will forget when you talk to me like that. So just a gentle reminder, sir. Gentle reminding you about the thing in the YouTube channel or the different notes. Because I have all intentions of doing all that I can for you so you can be successful. So I don't take your time, and especially this extra hour for granted. I'm going to ask that you don't do any work after class now. Those who need to go fresh up, get something to eat, cool off a little bit, then you go sleep, and then you get up and get some work done. All right? If there are no questions of me, I will bid you good night. Say your prayers before you go to the bed, and you should sleep fine. All the best.
Sir, right now my belly full, sir.
Nice.
What questions we're supposed to do? I got kicked off.
The questions that I am going to be sending those questions from the bunches towards in the handout that I'm going to send you. I'm going to be copying. I'm going to be copying some of the do knows. Like example 1. And let me tell you what I'll do, because I don't want you to be so lost when you're doing the stuff. You notice my example 1, example 2 have their solutions. My examples 3 and 4 don't have any solutions. So I may not even send you example 5 because I may want you to just work on examples 3 and 4 for me. That's exactly what I'm going to do. Ask you to work on examples 3 and 4 for me, and then you know, we'll just get it sorted out. But please, my final thought for tonight: if ever I get the feeling that you guys are taking it takes a lot of preparation, students, to type up all of them something here and to prepare for you. I really want you to appreciate it, and the only way you can show me appreciation is by doing the work. I want to get the results, and you know, it gives me the encouragement. So please don't make it gather dust. Do what you must. Oh, that's all right. All right. Have a good night. Later.
Good night, sir.
Good night, sir.
Man, take care.
Good night, sir.
Yeah, man, take care.
Mr. Shan,
Yes, pumpkin.
you know, say rhyming is your calling, not teaching. Earlier you said teaching is your calling.
It's all right, Miss Shan. Again,
Sir,
catch one
thank
for you.
you. All right, thank you,
Bless your
and I
heart. Bless your heart.
appreciate your efforts.
Thank you, CDB. Later.